So now we can talk about the definition of conservative property. So conservative properties are properties that can only change via advection and diffusion. Okay, advection is another word for the movement, okay? And diffusion is another word for mixing. So these are processes that operate across the faces of the control volume. Okay, so they create an influx or an outflux of your property through any or all of your 6 phases. And I will give you a tutorial on advection and diffusion. There are fundamental physical processes in influence. So what it means is that conservative properties don't have any other source or sink. Okay, no chemical reactions or no radioactive decay or stuff like that. So the equation for conservative properties is written here, is that the change of the concentration of C is just given by the sum of the fluxes through the phases. Okay, so there is no internal source or sink. Temperature and salinity are examples of conservative property. Okay, because there's no internal sink, there's no external source of temperature, of heat, or of salinity in the ocean interior. Okay, and that's important to understand too. Okay. All right, so just going over to the next slide is what is a non-conservative property. For non-conservative property, there's an additional term in here, okay, which is called int in this or int. What it means is that the concentration can also vary because of other features. It can be a chemical reactions or it can be biological features and biochemical processes. And dissolved gases such as dissolved oxygen are examples of non-conservative. So it is much more tricky to work with non-conservative properties in the ocean. Okay, because of these additional, sometimes non-linear interactions with other properties. Okay.